This is lesson 1.3 on measuring segments. So first of all, a definition. Two segments that have the same length are called congruent or congruent. Now, two things. First of all, on a picture, if you want to indicate two segments are the same length, so let's say this is segment AB, and let's say this is segment XY. To show that they're the same length, to show that they're congruent, we're going to put little hash marks on them. Now let's say in your diagram you have more than one set of congruent segments. That's a triangle. What do you call a triangle that has two congruent sides? That's an isosceles triangle. So suppose that these two legs were congruent to each other, then you would put two hash marks on them because they're the same as each other, but they're not the same as the two that back here were congruent. So if you have three congruent pairs, you would mark the third pair with three little hash marks. It just pairs them up. Okay, notation. The notation for showing that two segments are congruent is you say segment AB is congruent to segment XY. Now, notice that when you have the bars here, you have the little tilde. So that's a tilde with an equal sign underneath it, and it says that the segments are congruent to each other. That refers to the segments. Segments are objects. Objects are congruent. You can have congruent triangles, you can have congruent angles, you can have congruent circles. All kinds of objects in geometry can be congruent. However, if you want to refer to the lengths of the segments, you would say AB is equal to XY. Notice that no bar over top of the segments, no tilde in the notation. Okay, AB and XY are referring to numbers. Numbers are equal. Okay, numbers are equal. So, just for clarity here, if you write AB with no segment mark over top of it, it represents the length of segment AB. Okay, so again, the notation says that if you are referring to segments being congruent, segments, you make the congruent symbol with the bars. Okay, and if you want to talk about the lengths of the segments being the same, the lengths of the two segments are equal, you're using an equal sign, and notice that there's no bars up here. So that's a notation type thing, and I want to make sure that you're clear about the difference between the two. Again, objects are congruent, numbers are equal. Okay, remember that the terminology postulate, second idea here. A postulate is a statement that is assumed to be true. That was something we talked about in a previous lesson. So there's two more postulates in this lesson. The first one is called the ruler postulate. Honestly, the ruler postulate is not a postulate that we directly use very much, but it's kind of the idea behind measuring on a number line or measuring a segment. So the ruler postulate basically says you can take any line and turn it into a number line. So we can throw a measurement unit on there. So we can measure in units, we can measure in inches, we can measure in feet or centimeters. So basically it coordinatizes any line. So remember, a postulate is supposed to be easy to understand. I mean, we're used to turning a line into something with numbers on it so that you can give the coordinates of a point location. So say, for example, on a segment, let's say on a number line here actually. So maybe this coordinate of point X is at 5. And then maybe the coordinate of point Z is at, let's say 9. Okay, so you're used to saying how long is segment XZ? Well, that would make this 7, so 6 and 8 So from 5 to 9 is 4, or you could count 1, 2, 3, 4 units. Now, other than counting, how can you find the length of that? Well, notice that 9 minus 5 is 4. Right? 9 minus 5 is 4. Now, what if your buddy did 5 minus 9? Well, they get negative 4. Why does it not make sense for negative 4 to be the distance between the points? Because distance is never negative, right? The length of a segment can't be negative 4. So when you talk about how to find the length of a segment or the distance between 2 points, we always take the absolute value of the number. Now, what does absolute value do? Remember, the absolute value leaves a positive number alone, and it leaves 0 alone, but it takes a negative number and changes the sign. Okay, that's because it's representing the distance from 0 on the number line. So if you were to subtract the larger number minus the smaller number, it comes out to be a positive value, so you can kind of ignore the absolute value. However, if you subtract small minus big, you have to take the absolute value. Okay, so this is how you find distance on the number line. Now remember that you have seen before how to do distance in a plane. So let's say you have points x1, y1, and x2, y2. You have talked before about how to find the length of this segment, and that's in 2 dimensions. Okay, so in 2 dimensions, the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, hopefully that was familiar to you. If you don't remember the distance formula, it may have been toward the end of Algebra 1. We will be reviewing that again in geometry later on this chapter. But I just want to point out that this is in 2 dimensions. So wherever this second point is, if you're finding the distance between those 2 points, we're in a coordinate plane here. And so we need to use this more complicated formula. For the problems that we're doing in this chapter, we're looking at distance on a number line. Okay, so distance on a number line, we're in 1 dimension, so we don't need to worry about that square root formula. Okay, the length of a segment is the same as the distance between its what? Well, the distance between its endpoints. Oops, let me make that bigger. Okay, so again, let's go back up here where we're talking about the length of the segment. If you write the 2 endpoints of the segment without the bar over top of it, you're referring to either the length of the segment or the distance between its endpoints A and B. The distance between its endpoints A and B. How far it is from point A to point B. So again, if you have the bar there, you'd be talking about the actual segment. You take away the bar, you're talking about the length of the segment. It's a number. Okay, so the length of a segment, just like I said up above, if we want to know how far apart 2 points are, we're going to subtract the coordinates and then take the absolute value. Okay, subtract the endpoints coordinates and then take the absolute value. And again, the purpose of absolute value is to make sure our distance is positive. So absolute value does not change a non-negative number, but a negative number will then become its opposite. So again, the distance between points A and B is the absolute value of the difference of the endpoints. So it doesn't matter if we go big minus small or small minus big. Okay, so how long is segment ST? Well, here's S and here's T. So a couple ways to think about this. You can count. Now if you count, why is it wrong to do 1, 2, 3, 4, 5, 6? Well, because notice we're going by twos, right? So when you count by twos, you're going to have to go 2, 4, 6, 8, 10, 12. Now, how else can you get 12? Well, you might count and say, well, to the left of 0, we have 4, and to the right of 0, we have 8, so therefore that's 12. Like, that kind of makes sense, right? That's a distance. Sometimes the numbers aren't going to be so nice, though. So remember, the way that you find the length of a segment is by subtracting the endpoints and then taking the absolute value. Okay, so if you started with 12 minus negative 4, sorry, not 12, 8 minus negative 4, then that double negative there would become plus, and then that will turn to the absolute value of 12, which is 12. Had we subtracted the other way, if we did negative 4 minus 8 in absolute value, that'd be the absolute value of negative 12, which would also come out to be 12. Okay, now again, the idea is take the absolute value of the difference so that you don't have to worry about the distance coming out negative. Okay, the distance from V to S. Well, from V to S, we're going from negative 4 to 14. So 2, 4, 6, 8, 10, 12, 14, 16, 18. And that makes sense because we have a distance of 6 right here. So if we add 6 onto our 12 that we had before, we'd have 18 units. Now again, if the numbers are nice and simple, you can just count, especially if you have a picture there already. But if they're decimals or fractions or something not very nice, you need to make sure you understand this little formula right here. Distance on a number line. Okay, third idea. Suppose that G lies on segment XY. So I'm going to draw a picture because every time that there is a description of a diagram, the first thing you should get in the habit of doing is drawing a picture. So G is somewhere on segment XY. Okay, and if you're told that GX is 5, so if you know that this is 5, and you know the whole segment length is 12, okay, because it says XY is 12, how long would this segment over here be, GY? Well, hopefully that's obvious that it's going to be 7 because 5 plus something has to equal 12. That something better be 7. Well, we just used what's called the segment addition postulate. The segment addition postulate is going to come up all the time in geometry. We'll use it all year long. This is not something that we talk about in chapter 1 and then don't see again. It's going to come up all year long. So the segment addition postulate is one of those things that's really super helpful, but it's also pretty simple. Okay, so it says, suppose that 3 points A, B, and C are collinear. Okay, so we have a segment that has A, B, and C on it, but it says B is between A and C. So our endpoints would be on A and C, and B is somewhere on that segment. So I don't really know where it is on B, it's just somewhere on B. Okay, the segment addition postulate says that the distance from A to B plus the distance from B to C is equal to the length of the whole segment, which is AC. Okay, notice it's saying that the short segments added together. Okay, add the two short segments together. The sum of the two shorter segments adds up to the whole entire segment length. So you want to make sure when you're using the segment addition postulate that you're doing short plus short equals long.